f of x is equal to 5x squared minus 3x squared. Now the double prime would represent the second derivative, right? So the first derivative f prime of x, you can write this as dy over dx, or the rate of change of y with respect to the rate of change of x. So the second derivative, you can actually look at the derivative of the derivative function, right? And the way we write this as d2y dx squared, okay? So that's the second derivative function. Now, in this case, our function, f of x, is equal to 5x squared minus 3x, and the whole thing here is squared. The first derivative function we can determine by utilizing the chain rule. So I'm going to first use the power rule, so you get 2 times 5x squared minus 3x. Then what you do is you do the derivative of the inside, so you do the derivative of 5x squared minus 3x. So here you'll get 2 times 5x squared minus 3x, and then derivative of the inside, you'll basically get 10x minus 3, okay? And you can leave your answer like that. There's really no point in expanding. However, you might want to think about expanding. You could think about expanding if you're looking at the second derivative, if you didn't want to use the product rule. That's really up to you. I can tend to do this both ways. You should see the same answer. So I'm just going to go with the product rule. So it's a good way to kind of practice some of these derivative rules. If I was going to look at this using the product rule, right, how I would look at this, so f double prime of x is the derivative of the first derivative function, which we already kind of found here, right? If I use the product rule, I'm going to leave the 2 out here. I'm going to do the derivative of 5x squared minus 3x. Right, we can multiply the 2 out afterwards, right? I'm going to put the 2 in a larger bracket, right? So you know what we could do? I don't think I need to use double brackets, so let's put the 2 out here. Derivative of 5x, I'm going to put the 2 out here fully. And just work on finding the derivative of the inside. Okay, so we'll do the derivative of the left times the right, 10x minus 3, plus the derivative of the right factor, 10x minus 3, times the left factor, 5x minus 3x. Okay, and then we're going to use the giant square bracket, right? And in this case, we basically get derivative of 5x squared minus 3x. So we're going to get 10x minus 3 times 10x minus 3 plus derivative of 10x minus 3 is 10 times 5x squared minus 3x. Okay, then what you could do is you could expand this guy out, right? So this is kind of like a squared minus b squared. So if I use the expansion, you get a squared, 100x squared, minus 2ab. So pretend this is a and this is b. Okay, so 2ab is going to be like minus 10x times 30, which is 30x times 2, which is 60x, and b squared plus 9. Okay, so that saves us a lot of time. Plus, I'm going to expand this guy out. So you get 50x squared minus 30x. Okay, so you get 2 here. This is the second derivative. And then what I'm going to do is I'm going to just kind of collect all the like terms. So you get 150x squared minus 60x minus 30x minus 90x plus 9. Okay, and that's your second derivative function. Okay, now you want to figure out the second derivative function of 3, right? So you basically will get 2 times 150 times 3 squared minus 90 times 3 plus 9, and all I'm going to do is crunch this out in my calculator, right? And this gave us 2,178. Okay, so that's the answer for this, the second derivative of 3. And you can also do this another way, where you can actually kind of expand this guy out, right? And basically use, and then you can basically use the, you can expand out, and then you can basically just use some of the rules that we looked for polynomials, the power rule, the sum and difference rules, and so forth, and the constant rule, right? And then differentiate. Okay, so I think this one is a lot more easier, but I wanted to specifically look at the product rule because I think this would be it would just be a lot shorter in terms of the steps. Okay, so you guys can kind of try this out by differentiating, but I think I'm just gonna show you guys with the product rule.